Hello and welcome, and I would like to thank you personally to the committee that already give us the time to present it, our working result. And today I would like to present you our title Improve Value of the Temperature Difference on the Hot Box for Thermal Tests by me myself Dwinanto Sukamto. I'm from ECUBE University of Strasbourg, France, and you can contact me by the email that you can show on the slide. And next, for easy to present it, I would like to present you first time is the context, and the second one is presentation of our device, and the third section I would we would like to present you our experimental result, and the finally is conclusion and perspective. And to contribute to the reduction of energy consumption and greenhouse gas emission, our research objective is contribute to the energy performance of building through the study of a bioclimatic wall, ventilated wall, or pareto-dynamic insulated wall. And our objective today is preliminary result of improvement to temperature ambience of the hot box. For the second one, I would like to present you the study bibliography. There are many researchers working with the ventilated wall, and we present you two researcher. One is Francois Glorian in 2014 with the title Characterization and Modeling of Three Glass Pareto-Dynamic Windows at the Laboratoire Génie Civil et Geo-Environnement. And the second one is Remy Graffet in 2016 with the title Experimental and Numerical Study of the Energy Performance of Pareto-Dynamic Windows. He integrated to the laboratoire the science, the l'ingénieur pour environment Lassie University of La Rochelle. And our publication is in 2018 numerical study of ventilated facade for the preheating of air, which already published poster in conference COFRET 2018 in INSA de Strasbourg, France. And our originality of experiment is variation in the thickness of the cavity of the ventilated wall and variation in the airflow. And to introduce our ventilated wall, the ventilated wall is non-hermetically sealed channel for fresh air supply. You can see at the between the wall there are channel. The channel are ventilated, and the ventilated channel have the purpose to generate of convective exchange along the wall axis and disturb of the radial heat flow between the indoor and outdoor environment, and the valuation of solar gain in the preheating of fresh air. And our material used are aluminum composite. The color is gray and the thickness is 3 millimeter, and the thermal resistance is 0.008 meter square Kelvin per watt. and dimension, and also you can see from the presentation today. And to present it, our hotbox produced by the company Ineltech and financed by the Arcanic Foundation. As you can see, our hotbox have two climatic chamber, and each climatic chamber can guarantee the production of hot and the production of cold by resistant thermal and the cycle of compressor cycle. And our hotbox having a range of minus 30 to plus 60 degrees Celsius for temperature and 10 to 98% for humidity. In our general diagram of acquisition system, as we can see from the slide, is our hotbox have two chamber climatic, and in between the chamber climatic there are sample holder. And our hotbox connected to two data acquisition system. One is data acquisition by multimeter Catley 2700 with 60 channel, and our data acquisition Catley connected to Tipka thermocouple, which have the brand is RS, and measurement range minus 75 degrees Celsius to plus 250 degrees Celsius. And we are also employ the Flux Matter Total brand Captech Enterprise with uncertainty plus or minus 3% from the result, from the measurement result. And we are also use the thermal camera FLIR T650 SJ with the measurement range minus 40 degrees Celsius to 150 degrees Celsius with uncertainty plus minus 1%. And there are also national instrument with connected with hot wire anemometer, and our anemometer installed to the isolated ducting, and from isolated ducting we use the DC fan and controlled by DC control power supply. And for instrumentation of climatic chamber, we install three thermocouple at the chamber climatic, each chamber climatic. And you can see also we installed three type K thermocouple in the chamber climatic for the hot side. And our experimental condition, we set point at the fixed cell hot 20 degrees Celsius 55% in relative humidity, and the other is 0 degrees Celsius with 75% relative humidity. And our condition test is steady state condition, and our cavity distance between 5 millimeter and 10 millimeter, air debit 10, 15, 20 meter cube per hour. We are not yet to present you the result of the thermal performance of our ventilated wall, but for the first time I would like to describe that our first setting point 0 degree Celsius 75% and 20 degrees Celsius 55%, it's not matched with our expectation setting point, which is our setting point is 20 degrees Celsius in a different temperature. Here we presented you the preliminary result. Before we started the experimentation, we do the cold junction correction. We test the Tipka thermocouple with the to to submerge at the mixture of liquid and ice, which is we know the mixture of liquid and ice is 0 degrees Celsius, and our data acquisition show the result. The measurement result is 0.03 degrees Celsius. And here are the result of our instrumentation result. We can see at the up 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 graphic, we can see the steady state condition is our setting point, and around the setting point there are evolution of temperature. There are the measurement by the hot box instrumentation, and we can see from the three Tipka thermocouple, it show the homogeneous temperature. There are around 16 degrees Celsius, and the other side measurement result of air temperature at the cold cell. It's same thing. We set the temperature 0 degree at the set point, and our hotbox instrument measurement, it measure the evolution, the temperature that you can see. It's near 0 degree in average, and our three thermocouple, Tipka thermocouple, they measure the homogeneous result. In average is a minus 2.5 degrees Celsius. So the difference of temperature 16 degree at the previous, and minus 2.5 degrees Celsius, it means we have the delta temperature is average is 18.5 degrees Celsius, and this setting temperature is not yet to our expecting temperature difference is 20 degrees Celsius. So we do the improvement to temperature at the cold side. Before it's 0 degree, and after I will show you, we stay to keep the same point. We keep to same point at the hot side, and the result is 16 degree. Okay, 16 degree in average. The temperature is homogeneous, and we change from 0 degrees Celsius to minus 2 degrees Celsius, and our Tipka thermocouple show the result. It's minus 0.5 degrees Celsius. It's mean the previous is 16 degrees Celsius, and the other is minus 4.5. It means our temperature difference is 20 degree, 20.5 degree in average. It means Our setting point in this case is accepted. And in perspective, the Cole-Johnson correction values show a good agreement value of measurement by Catley 2700 data acquisition, and the value on configuration condition setting to hotbox. It must be corrected to value minus 275 minus 2 degrees Celsius 75% humidity and 20 degrees Celsius 55% of humidity. So the result have an excellent agreement value to reference parametric value and perspective. The next experimental activity setting point 20 degrees Celsius 55% and minus 2 degrees Celsius 75% will use as a fixed parameter. And I would like to thank you for your attention. It's me, Dwinanto Sukamto, and our co-supervisor is Francois Gorion, and our director of tests is Monica Siru. Thank you very much and have a nice weekend.